Hi, I am Yamuna and this is my part for the calculation. For the peak controller, the value is already given Kp 2.2, Po is 50%. So the value of T starting from 0 and end with 12. So to find the M value, we need to use this equation, and to find the C value, this equation, and following with error equation, controller output to find the p-value at the end. We need to use these steps for all the calculations which start from 0 to 12. 0 to 12. The same steps as we used for the first one. And then these are the tables for the P controller, time versus controller output. And I already did the graph as shown here, which is the value is decreasing, increasing, decreasing, and at the end the value is constant. And for the second part, PI controller, the value is given also, which is KP is 2.2, KI is 0.7, and PO is 50%. And this is the formula given for the PI controller. And as shown here, the T is starting from 0, which is in the question paper is already given. In the graph, the value is starting from 0 to 12. So we must use this equation to find the P formula. And first of all, we must find the EP first. And at the end, we must find the P value by substituting the time. And we must follow these steps for all the calculation that's shown here, which is starting from 0 and again end with 12. And this is the value for the PI controller, which is the second is starting from 0 to 15, and the value which start from controller output value which start from 50% and end with 51.43%. And these are the graph I plotted. As you can see, the value is decreasing, increasing, and at the end it's keep constant. So these are the calculation and graph and the table for my parts. That's all. Thank you.
Hello everyone, my name is Xia Wen Hong and my material number is B0820100043. So today I will present about our project process instrumentation which I conducted is for calculate the PD and PID controller for the figure 1 and figure 2. So this is about the flow measurement control system. So as our group is group 3, so you can see here this row is our appendix value of all the parameter values for the continuous controller. So first of all, how we calculate the PD controller. So first, we use back the error equation that we obtain in the P controller. So the error equation that we obtain in the P controller is equal to negative 2t. So we just use back the equation, and also as we know, the proportion output value for the PD controller is equal to Kp multiplied with the EP plus Kp multiplied with the differential of the error equation plus the proportion output. So we just substitute the Kp, Ep, Kd, and also the differential of the arrow equation value inside this equation. So we will obtain 2.4t 2.4t plus 48.08. So after this, as we want to obtain the proportional output for the 0 second until the 2 seconds, so we just substitute the t equal to 0, 1 and 2. So we will obtain 48.08% for the proportional output when the t equal to 0 second. So and when the t equal to 1 second, the proportional output equal to 50.48%. And also when t equal to 2 seconds, the proportional output will be 52.88. So for the rest calculation from the 2 second until the 15 second will be also the same. We just change the EP equation from the, we just change the EP equation and substitute it with the space with the following time second. So and we just using back the parameter value for the proportion gain, also the derivative gain, and also the proportion output at the 0 second, and just substitute back, we will obtain the following result. So it's like this. For as an example, when t equal to 2 seconds, we will obtain 49.04%. So we will do the same steps to calculate the PD controller until the 15 second. So after the 15 second, we will obtain the proportional output for the t equal to 15 second is equal to 50%. After that, we will tabulate all the data that we calculate for the PD controller. So if you like this, the 0 second until the 15 second. So for the next part, before we go into the PID controller, so this is how the graph pattern for the PD controller for the flow measurement control system. So now we proceed to the PID controller. So the PID controller, the proportion gain equal to 1.2, the integrate gain equal to 0.7, and the derivative gain equal to 0.8, and also the proportion at the 0 time is equal to 50%. So same step as the PD controller, the equation the error equation is equal to negative 2t when the time is smaller than the is bigger than the 0 but smaller to the 2 seconds. So the error equation equal to negative 2t. So after that, we just substitute all the information here inside the proportion equation. So we obtain the negative 0.84 t power 2 minus the 0.24 t plus 48.08. So and also just substitute back the value of t from 0 until the 2. So we obtain the proportion output at the specific time second at the moment. So the same step also repeat. We just substitute just change the arrow equation for the following with the time second that we want to calculate, and also the proportion output at that second. At that second, just refer back to the PI controller value that we obtained from the previous part. So this all we are going use the same step until the time second equal to 15 seconds. So we will we will obtain the value like this. When the time equal to 15 seconds, we will obtain the proportion output is equal to 51.43. After that, we also tabulate all the data that we calculated in this table. So example like this, and also we will transfer all this data into this graph. This is how the PID controller graph pattern. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Adini Megawanuddin. My matrix number is B0820-186. So today I'm going to explain about our project calculation, which is proportional P controller. So the requirement has been given in the question, which is here our group is G3, so here is our requirement that has been given. And then, so right now I'm going to proceed with my explanation. Okay. So based on the requirement given, which is proportional controller, KP equals to 2.2, P output equals to 550%. And then, so this is our formula that has been given. Okay. Which is M equals to Y2 minus Y1 over X2 minus X1. So, and then this value we got from here lah. We got from here, which is the graph for error for level measurement control system. And then, so when we calculate the what we call it, kecenderungan dia punya ni, and then when we got M, okay, we substitute M equals into the formula Y equals to MT plus C, and then we got value for C, and then we use error equation EP equals to MT plus C, and then uh, this is our equation for EP, error equation. And then for the formula controller output, P equals to KP, EP plus P out, which is when we got P, we can just substitute time. Okay, so for example, when T equals to 0, we substitute 0 into T, and then we got 50%. And then at 1 second, we got 56.6%. At 2 seconds, we got 63.2%. So it's all the same with all of this equation, with all the calculation part for the F, G, and also H. So and then here is our result for the overall calculation, which is when when time at 0, our controller output equals to 50%. When time equals to 1, our controller output 56.6. And then when 2 second, controller output 63.2%. At 3 second, 50%. At 4 second, 43.4%. At 5 second, 50%. At 6 second, 56.6%. At 7%, at 7 second, 42.8% controller output. At 8%, at 8 second, 50% controller output, and 9 second equals to 50% controller output, and also the same for 10 second, which is 50% for controller output. So this is our graph for P controller. This is our graph, this is our value based on this data here. So this is our result. Okay, and then I'm going to proceed for PI controller. Okay, so based on the requirement given, which is I already showed earlier before. So here is our requirement, which is KP equals to 2.2, KI equals to 0.7, P output equals to 50%. So okay, so at first we need to look for power output for each of these graph lah. So what happen when times from this period of time and then to period of time? There's different on the M, right, for the value for P value. Okay, so here's we can see okay, here first uh, to get value for P, we use this formula which is P equals to KPEP plus KPKI and then APDT plus P out. Okay, so P, we get the equation for P, and then so by times equals to something value something, we just substitute T into the equation and then we get the value for P lah, P out. So this is our value. For example, at T equals to 0, P value for P is 50%. Okay. So it's the same with the rest lah. The same okay, it's the same. Okay. Okay, okay. As we can see here, we are looking for value P at 3 seconds, which is we get here 63.86 percent. Why we do this? Because based on the graph earlier, we can see that uh, the border, yes, the limit is 63.86% lah. And then when we got P equals to 3 times when 3 second equals to P, here we get here and then P equals to this one we use this formula, yes, and then we got the value, we got the equation. When we got the equation, we also substitute lah, like usual. And then okay, so it's all the same for the rest of the equation. And then okay, so uh, here's our full value, which is when time 0 equals to 50%, and so on. And as you can see here, when time equal to 6 second, value control output 68.15 percent. So it's the same as earlier on. Okay, so this is our graph for PI controller. This is PI controller is error. Okay, so we can see this is our graph lah. Okay, I think that's all from my part. Thank you.
Hello, my name is Abdul Hakim bin Mustafa, metric number B08 2010 251. Today I want to explain about my part for this project. Okay, first of all, this is uh, our appendix for our group 3. For my part, I will explain about the PD controller for the level measurement control system. For the PD, the given is KP equal to information given KP equal to 1.2, KD equal to 0.8, and P0 equal to 50%. Okay, this is a figure for the level measurement control system, and this is the graph error for level measurement control system that given. Okay, this is our the calculation that I calculate. For this PD controller, we use this formula P equal to KP EP plus KP KD and this is a formula given. So we calculate follow the from the 0 second to the 10 second for the for and we split to the sequence from 0 second to 2 seconds, 2 seconds to 3 seconds until the lastly until the 10 second. So we use this formula and we will get the P for the 0 second 52.9 percent. So when we get all the value from 0 second to the 10 second, we need to make a table time second from 0 to 10 and the output in percent. Okay, so when we get the table, uh, we need to make a graph, the controller output graph for the PD. So this is the output graph for the PD that I get from the result that I calculate. Okay, so I think that's all for my part for explanations. Thank you.
Okay, good day. My name is Tang Ikin. I will proceed with my group 3 for the part level measurement control system for the PID, sorry. Okay, so group 3 is the KP, KI, KD as the appendix ones. So here, so for KP, KI, KD, I refer back to the appendix ones. So for me, like calculate like for the part from 0 to 2, 2 to 3, 3 to 4, and 4 to 6 because there is the same the EP is the same, and then because of their gradient is the same, and then the 6 to 7, 7 to 8, and 8 and further. So okay, for part 1, 0, the T is the T is between 0 and 2, so so the P if the formula is KP plus KP integrate T from 0 to T for EP dt plus KD KP and differentiate of EP and dt plus P of 0 because it starts from 0. So the P0 is given by 50%. So from here we can calculate okay, so when T is 0, we do the calculation, and when T is the 0, P is 55.28%, and T is 1 is 64.19, T is 2 is the P is 77.72%. Okay, next for P2, I referring back to the PI value that doing by the adenine. So I refer back it. I can get the P2 is 59.24 and so on. Okay, the EP using back the Y equal MC to calculate it. Okay, so the calculation is same and so on. So, okay, so on. So as the result, this is the result at the end. Okay. So from this, I plot the graph by using Microsoft Excel. and I get this graph. Okay, that's all. Thank you.